Hey guys, a very good morning. Thank you for joining with us. My name is TN Pradeep Kumar Naidu, and we are here to represent Nikit Engineers, which is into welding from the past 42 years. And the kind of knowledge that we have gained over the past 42 years, we would like to share it with you guys to solve a much complicated problems of welding and simplify the entire process. So let's see what we're going to solve today.
So the problem that we are solving today, guys, is a stator plug welding. So what's a stator? A stator is a stationary part of a motor. It can be an induction motor or an electric motor. So let's look at the kind of welding that we're going to do today. If you see the entire image here, you can clearly observe that there is a shell, the outer layer, and an internal layer of coil, and the place that where we are doing plug welding. Now if you observe this clearly, I'll set another image where it is very clear that how we are going to plug weld. Plug welding is nothing but fastening of two metals by welding. We are going to fasten the top layer of the shell to the core or the stator portion of the entire motor. If you look at the component, the outer shell thickness is around 4 to 6 mm. The diameter varies from 350 dia to 450 dia, and the length again varies from 415 to 550 in length. The internal portion, as marked in orange, is the coil which gets fitted into the shell. Now let's look at the machine. This was the final concept that we developed before dispatch or before trial. The initial concept involved the main rotary system, what you can observe here where the shell is located. Now the linear axis that you can observe here is made of x-axis, y-axis, z-axis, and the torch holder with the wire feeding mechanism. For the entire system, there's a body frame, and the body frame consists of again two elements. One is the actual frame for the axis and the actual frame for the component. The frame for the component has got bearings, basically ball bearings, where the load rating of each varies from 200 kilos to 400 kilos. Now on to the side view of the system, what you can observe is there's a pointer mechanism where the entire shell is positioned based on this reference point. Once it's referenced, there's a pneumatic clamping mechanism which holds the component in position. Once it's done, you can also observe that post development of the initial stage, we moved on to this new particular design. This is the complete roller assembly where this attachment gives value for easy removal and loading of the component. Now, looking at this entire system, you can observe that the roller assembly which we have added over a period of time after testing can be easily removed and put forth. So, if there is a bigger or a lengthier model than the current one, we can as well increase or decrease the size of the rollers. Now there's a wire feeder stand as well for ease of wire feeding system. The wire feeder used here is 0.18 to 1.1. Let's take a look at the video of the welding. Basically plug welding with the wire feeder. The axis moves to its position. This is during trials. So as the axis moves to the position, arcing starts and wire feeding initiates. The wire feeding used here or the wire used here is 1.2 mm thick. You can clearly see during the weld process the plug weld is very evident. That is, the sheet, which is about 6 mm, the shell, gets melted onto the core of the coil. This is how plug welding is done. The advantages of plug welding is to keep the shell intact with the coil inside. Instead of clamping it or riveting it or bolting the shell to the coil, the entire shell is plug welded and the strength of it is really high. You can also see the kind of finish that we achieved in this process. It's done in TIG with wire feeding and the finish is really good. Let me show you other components how we have done. Each component has got about 4 positions. All the 4 positions the entire system takes care of in a single sequence. That is how you can see different positions of the weld bead. Now let's move on to the costing of the entire project. The project name was GL190. It's a Stator plug welding automation, and the process is stick welding with wire feeding. Talking about the inclusive costing, it's a 4-axis motion controller with a 4-inch display costing $2,200. The linear 3-axis assembly, that is X, Y and Z, there is no X2 here. So 1 meter, 0.5 meters and 0.3 meters, it's about $2,100. And wire feeder assembly is about $683. Torch, $175. Fixture assembly, $2,100. And frame assembly is about $1,420. Safety system, $650. You may also note that all motors are stepper. Hence, the power consumed is hardly 500 watt-hour. Now, the total price of the BOM sums up to $9,328. The non-inclusive cost, which involves labor, company overhead, consumables, power consumption, installation, and packaging and forwarding, relies completely on individual companies. Now, we also move on to the next episode where we will discuss about the next problem that we're going to solve. Thank you so much for watching, guys. We'll see you around tomorrow. And as of now, happy welding and a great day ahead. Thank you so much.